This is Dr. Karnik with New Ed Science Academy. We are going to be working on a question in thermochemistry. This question is about heat transfer in a coffee cup calorimeter. So let's look at the question. When it comes to a coffee cup calorimeter, it is important for us to understand who is the system and who is the surrounding. So in a coffee cup calorimeter, two things are happening. One is, so let's see if this is a coffee cup. You're going to be seeing a chemical reaction happening. This is the chemical reaction. And this coffee cup calorimeter is going to have a liquid surrounding the reaction. In other words, the reaction is in an aqueous solution. So the solution surrounding the reaction is the surrounding. In other words, the reaction happening is the system and the solution is the surrounding. Therefore, when we are looking into heat transfer, we can say that Q reaction is equal to negative Q solution. So now keeping this in mind, let's look into a question for coffee cup calorimeter. So here it says that a zinc metal reacts with HCl as per the balanced equation. So this equation that is given to you, that is the chemical reaction. That is the system. When 0.103 grams of zinc is combined with enough HCl to make 50 milliliters of solution in a coffee cup calorimeter, all of the zinc reacts, raising the temperature of the solution from 22.5 degrees Celsius to 23.7 degrees Celsius. Find delta H for this reaction as written. They have given us the density of the solution, and 4.18 joules per gram degree Celsius is the specific heat capacity of the solution. So let's look into how to solve this question. So again, the best way to work with any of the heat transfer questions is to separate out what is the system, what is the surrounding. So accordingly, I'm going to write down the reaction, the data that is given for the reaction, and the information that is given for the solution. So in this case, when I'm looking into the reaction, I'm seeing 0.103 grams of zinc is part of the reaction. It is combined with HCl to make 50 milliliters of solution. As we know, 50 milliliters of solution is the surrounding. All of the zinc reacts, raising the temperature of the solution from 22.5 degrees to 23.7 degrees. So in other words, I know that the final temperature of the solution is 23.7 degrees, and the initial temperature is 22.5 degrees. Find delta H for this reaction. So they're asking me delta H. And use 1 gram per milliliter for the density of the solution and 4.18 for the specific heat capacity. So I see the specific heat capacity, joules per gram degree Celsius, and they have given me the density. So the density is equal to 1 gram per milliliter. All right, so let's see if we can calculate the Q of the solution given this data. So Q solution is equal to mass times specific heat capacity times delta T. So this is equal to, let's look into mass. So in this case, I have 50 milliliters of solution, and I know that the mass needs to be in grams. I also know the density of solution, which is 1 gram per milliliters. In other words, if I had 1 milliliter of the solution, the mass was 1 grams. Since I have 50 milliliters of solution, I know the mass is 50 grams. I multiply it by the specific heat capacity, which is 4.18 joules per gram degree Celsius, and multiply it with delta T, which is final minus initial, that is 23.7 minus 22.5 degrees Celsius. So this comes to 50 grams times 4.18 joules per gram degree Celsius times 23.7 minus 22.5 is 1.2 degrees Celsius. So when I do the calculation, I get Q of the solution is equal to 250.8 joules. Now that I know the Q of the solution, I'm going to go ahead and calculate the Q of the reaction. Again, we know the relationship. Q of the reaction is equal to negative Q of the solution. So Q of the reaction is equal to negative 250.8 joules. But what are they asking me? They're asking me what is the delta H of the reaction. When they're asking you questions on calculating the delta H of the reactions, it is implied that you are looking at the reaction and you are informing how much amount of heat is required for this particular reaction in play. And in this case, for this reaction, when it comes to zinc, I'm looking at 1 mole of zinc. The number of moles of zinc is basically given by the stoichiometry of the balanced chemical equation. And I do the calculations for 1 mole of zinc. Now, this Q of the reaction that I'm getting based on this calculation is for 0.103 grams of zinc as given in the question. The question says when 0.103 gram of zinc is combined with HCl, these are the results obtained. So this reaction is about 0.103 grams of zinc, and this is the Q for the reaction. So now the first thing I want to do is I want to calculate how many moles is 0.103 grams of zinc. Looking at the molar mass of zinc, I know 1 mole of zinc is equal to 65.38 grams. Therefore, 0.103 grams of zinc is equal to 0.103 multiplied by 1 mole divided by 65.38 grams. And this equals to 0.00157 moles of zinc. So now to calculate the delta H of the reaction, I'm going to divide the Q of the reaction by the number of moles of zinc, because I need to calculate how much is the heat per mole of zinc. So this is equal to negative 250.8 joules divided by 0.00157 moles of zinc. And my answer comes to negative 1.6 times 10 to the 5th joules per mole. This is the delta H of this particular reaction that I'm looking at. And as you can see, since the quantity is negative, this reaction is an exothermic reaction.